Hello guys, I'm back with another episode of machine learning, and today we are going for the most basic problem in machine learning, that is the classifying the iris dataset, and it is very easy to understand and even more easy to execute. So let's start with Jupyter notebook without any delaying. So at first let me rename this. Iris data set classification through machine learning algorithm. Let me rename this. Okay, before doing anything, at first let's understand what is the iris data set. Okay, I have opened the iris.name. Yeah, this plant data set has been created by R.E. Fisher, Donner, Mitchell, Marshall in 1988 by NASA government. So let's get more information about this. Okay, it has 4 information attribute, that is sepal length, sepal width, and petal length, and all those are in the CM, and it has 4 classes in which we are going to classify. So at first the iris setosa, the second one is iris versicolor, and the third one is virginica, and there's one more thing, and it has 150 classes, 150 instances, in which there is 50 in each of the classes. Okay, and it has also given the correlation. You can see the correlation here. The petal width and petal length have the high correlation as compared with others. So, and it doesn't have any missing value, so we don't need to go for the cleaning of the data. Okay, let's go into our Jupyter notebook. Okay, at first let us import the libraries. Okay, we are importing NumPy, pandas. So we don't need to import the pandas, but we are importing Seaborn and Matplot for the visualization. Import Seaborn as SNS. Okay, after this state we always go for the loading of the data. We don't need to download anything externally or export externally. So we will basically load the data set. We will loading data set through Seaborn. Actually, I have shown you how to load the data through pandas. Now I am showing you how to load the data set with the Seaborn. So let it be data SNS dot and its name is iris. Okay, so we have successfully loaded our data. So let's see the head of the data. Okay, and here we go. We have, as we have talked earlier, we have sepal length, sepal width, petal width, and species. In species we have the 3 classes, and they are iris setosa, iris versicolor, iris virginica. Okay, let's describe our table. Okay, you can see the sepal length standard deviation is 0.82, whereas petal length is 1.7765298, you can see the maximum value in the sepal length is 7.90, where in petal length, okay, actually the petal length has the highest, almost highest value than every one. You can see its count is 150 and its maximum value is 7 and minimum value is the 4. Okay, actually in the data set at first it has told us there is no missing attribute, so we don't need to check the missing attribute, but I want to check the missing attributes. So let me check. Simple, we need to call the is null function. If there is then it will solve the sum. So let's check. So we don't have any null values or missing values in our data set, so we will go for the data visualization, which is the most important process in the data analysis. So we will be going for EDA, exploratory data analysis. Through visualization. Let me mark this as heading. Okay, after this, so we need to see, okay, here the sepal length and sepal width and petal length and petal width. So we first will go for petal length. So plt dot fig my figure, fig siz size. Yeah, basically this statement is used for the creation of the axis. So it has told that it 14/6 axis. So actually I have taught you main thing about the other kind of plot. So today I have came with a new kind of a plot that is called the swamp plot. So using Seaborn libraries we will go for swamp plot. SWA swarm, SWARM swarm plot. X axis select the data, we will go for the classification. SPECI is species, and y equals to data. Actually we will go for the petal length or the sepal length. Okay, so it has clearly shown that, okay, you can see clearly that Virginia has the longest petals, wherein Cerotos has the shortest petal, and versicolor is in the middle. Okay, you can see clearly. So let's go for after petal let's go for sepals. Okay, you can see even the Virginica has the highest, so it has the longest sepal length, wherein Cerotos has the shortest length, and versicolor is always in the middle. So basically from this plot we can conclude that Virginica are the largest flower, wherein Cerotos is the shortest flower, and versicolor species are in the middle. So it is in between the Virginica, it's Virginica and Setosa. After this we have successfully drawn these two, and even you can conclude, you can analyze. Okay, after this I think let's go for a line plot to see the sepal length and the sepal width. So again, at first we need to go for PLT for drawing of the axes. And after that we will be using the Seaborn libraries for the line plot. In the line plot we need a data, because line means simple one data, because we cannot draw more than one in a single line, so we always go for a single. Okay, it should be sepal length data. Sorry. Sepal length, and let it be comma, and we go for a label. Let the label be sepal length. Okay, after this we'll be plotting another line plot in the same graph. So okay, let me copy this for the sepal length and sepal width. So I have copied this sepal length, and we are going for sepal width. Okay, so we can give a title. If you want, then you can give a title. If you don't want, then it's your choice. I'm just writing sepal length and width. And let me show this in the graph. Okay, so it's showing there is either X or Y. There is something error, so let me check the error. Okay, what is the error? Let me see again. Yeah. So let's scatter our plot. So we'll be using the scatter plot where we need the X, Y and hues. We needed 3 X, there must be Y, and this is the hue. Okay, so in X I'm just taking the sepal length. Okay, let's copy this. So X equals to for Y axis we are adding the petal length. We can okay, we'll be adding the petal length. Okay, so left length, this is also fine. Okay, and here sepal length, sepal width, and we'll be giving one more that okay, make a call it okay. So from here you can easily see the the scatter plot of the petal width. You can see petal width. So it has a scattered data according to the sepal width with respect to the sepal length. Okay, now we'll be dividing our data into the dependent variable and independent variable. Okay, let me see the heading. Okay, so here the x data dot ilog. In the independent variable, we must include the sepal length, sepal width, petal length, and petal width. Okay, and in the dependent variable, we must include the species for the classification. So I'm using the ilog. Okay, except the last row, it will contain each and every column. We need to include each and everything of the row, and I am just concluding only the last column here. So you can easily see these are the x. Sepal you can also verify 5.1, 3.5, 1.4. Okay, and in the y you can see the same setosa, virginisa. Okay, after this we always go for the model. We always split data into the training set and in the testing set. So for this we must include the sklearn from sklearn dot model underscore selection and import train underscore test underscore split. Okay. It's actually executing, but I think it's right. So it's executed. X train, X test, and into the white train and the white test. White test. Okay, so we'll be calling this function train test train and split. Here we need to give, at first we need to give the independent variable, then we must need to give the dependent variable. Okay, you must not dependent variables are the variables which totally depend on the other, that is the y. And independent variable means the variable which does not depend upon anything. And after this we must fix the test size. So I am taking the 80% of the data for the training set and only 20% of the data for the testing set. So we have included the test site equal to 0.2. You can change if you like. Okay, so we have successfully split our data into the testing and the training set. So after this we must go for the basically I go for the features scaling. If you don't want, then it's your choice, but I prefer features scaling. So here the sepal length, okay, it's like 5.1 and petal width is 0.2. so it after scaling it will came into the one scale. So let's better to scale. It's very important topic. It's very easy if you are doing with the pre-processing. Now we need to call it a scale, sorry, SCAL scale, and actually even we need to give for the X train. Basically Y train are the classification variable. You can see this Setosa, Virginsa. So we don't need to rescale the species for the Y variable. It should be X test one. I have it wrong here. It should be X, not Y, because Y are the dependent variables. Okay, so we have successfully scaled our training set and testing set. So let me check. Yeah, we have scaled our training set. Even if we type here test even. Okay, after this we will be implementing I will be implementing the three kind of machine learning classifier. Those are the k-neighbor classifier, and there is a random forest classifier, and third one is the naive Bayes. If you want, then you can use the logistic, SVC. There are a lot of classifier. Even you can go for the more kind of ensemble learnings, ensemble classifiers. Okay, so at first let's create a model for KNN. So we need to call the function of from Scikit Learn. We need to import from Scikit Learn. It's called neighbor. Neighbor classifier. Okay, after this, let me check if I have. Okay, there is no error. Let me copy this. It will be KNN. Okay, so KNN will be our model. Okay, if you want, then just press the Shift plus tab. Then you will see its parameter. It's like there must be n neighbor, a uniform, algorithms auto, your wish. There is a matrix called Minkowski, and here is the P. You can see the P. In P, actually Minkowski is a kind of a theorem or formula given by the scientist Minkowski, and P2 means Euclidean distance and P1 means Manhattan distance. It's your choice which you want to use, but basically I mostly prefer the Euclidean distance. So enable, it's your choice how many you want to give. And I'm using the Euclidean distance. So I think we have successfully built our model. Okay, so let's train our model. KNN.fit. For training we always need the X train and Y train. Okay, let me enter. So our model has successfully implemented and fitted well. So let me check the accuracy. Import accuracy underscore. Okay, so we'll be using, it's like, okay, let it predict see the predict. Yeah, see this method knn the predict of x underscore. So we are testing here, so we need to take the x underscore test. Then one accuracy underscore s. Test, and we must actually, this has predicted the value, and we need to pass another. We have passed here white test. These are the actual value. White test is the actual value. Now we will be giving the predicted value, PRED. Okay, so it gives us the accuracy of a 90%. Well, it's a good model. I think we have done a nice job. After this, we'll be going for the random forest classifier. Okay, random forest classifier are the algorithm of the simple learnings. So random forest searches the best result for our algorithm. So it always gives the high accuracy than the other algorithm most of the time. Okay, so it will be RDC. Just always copy this name, or else you might make it wrong. Okay, after this press Shift plus tab, and you will see, yeah, here is the like n underscore estimator equals to 1, citrons equal to Gini, depth equal to none. It's your choice, you can use these, but mostly I use an estimator equal, I'm using the 4, and citradian equal to, we are using the entropy based information gain. Okay, we have successfully built our model RDC for random forest classifier. Okay, if you want to fit, then you just need the exact code. Okay, instead of KNL, you just need to add our model name, random forest classifier, and that's name is RDC. So we are RDC. Okay, we have done it successfully. Okay, now we need to test our accuracy score. So just simply copy this code. Okay, most of the data. Okay, paste this. Its model name is RDC. Here is the KNN. So we will emit this, and we will be writing here RDC. Okay, the name is same, so don't need to worry. Okay, it's like 0.93%, means 93.33%. That's the nice score. Okay, we are doing well. Okay, after this we'll go for the naive Bayes, which is totally based on the conditional probability. Naive Bayes are the subset of the Bayesian theorem. Okay, if I will get a time, then I will make a specialized video for the Bayes theorem. I think it's a very interesting topic. Okay, I can promise you the next videos I will be using the Bayesian theorem, and I will be discussing about it. Okay, the same. If you want, you can copy this. Okay, GMB local store. Set. Replace this, and oh shit, it's showing that there is an error. So let's check what is the error. Okay, from Scikit Learn learn.nav bays import gaussin_nb. So where's the error? Cannot import the Gaussian NB. What's from? Let me write again. Oh shit, I have written the 3s. Okay, shit, here's the problem. Okay, we got it. That got it similar GAUSS. I got confused with 2s and 3s. So again we go for the same process. You just need to copy the code and pasting. You just need to change the model name GNB. Okay, we have successfully fitted we successfully trained our model. Now we go for the accuracy checkup. Okay, while see, again we need to change our model name. Our model name is GNB. Okay, doesn't matter if the variable become the same. So it's like 0.8%. So yeah, it has less accuracy. Okay, so from here we have used the 3 machine learning algorithm: KNN, ensemble learning, random forest. Okay, in ensemble learning we have used random forest classifier and we have used the naive Bayes, among which I think the random forest classifier is the best classifier. So I think it's better to use the random decision forest. And I hope you like this video, and if you have any doubt, then feel free to ask any kind of question in the comment section. And to watch more videos, please subscribe for more videos update, and please share. Thank you.